Hi, this is Mr. Minnick showing my AP Computer Science using Java students how they can use a shortcut to convert binary numbers to hexadecimal numbers. So let's review what we've learned so far. You know how to count in binary and so on. You know how to count in octal. Once you get up to 7, it goes to 1, 0, then 1, 1. And you know how to count in hex. Once you get up to 9, it goes to A, B, and then it goes to F. And then you start reusing your digits, and you have 1, 0. So you know how to count. And you know how to add numbers in these number systems, and you know how to subtract. And you know how to convert, but here's the catch. If I give you a big binary number like this, I taught you how to convert a binary number into some decimal number, base 10. See the notes or see previous videos. I also taught you how to take a base 10 number and convert it to binary. I don't know if this is correct or not. I'm sure it's not correct, but let's just pretend. So you can convert from one system. Let's just pretend that turned out to be 349.10, and this is the reverse of that. So you know how to do that. And if I change this to octal and throw some octal digits in here, you would know how to convert that to some decimal number, and vice versa. And base 16, you know how to convert. So that's all learning that already took place in this course. But today I'm going to show you in this video how to convert from a binary number straight to hex. Not to decimal, but to hex. Well, here's the long way to do it, that if this kind of a question were on the AP exam, it would waste too much time if you had to do it this long way. Here's how you could do it. You could sidestep and convert this to a base 10 number, because you've already learned how to do that up here, and then take that base 10 number and convert it to base 16, because that's also been taught before. But why take the extra time to translate it into this numbering system if there's a direct way to do it, which I'm about to show you? There's a slick way to go directly. So you can go straight from English to Russian without finding some German person who speaks both languages and can do the translating for you. Why bother with German when you can just find a trick to translate your English right into Russian? So here goes. Here's the number that we are going to learn to convert directly. It's this number right here that I already wrote down, 100 1110, whatever. So I'm going to rewrite it, but watch how I rewrite it. I start from the right, and I write it in groups of 4 bits, and I put a gap in between those bits. And the goal is, of course, to convert this to some hex number directly without going to decimal first. So here's the trick. You label your columns like we've already learned before. In the base 2 system, it goes 1, 2, 4, 8. But instead of going 16, 32, 64, 128 like we did before, you start it over again at 1, 2, and you go 4, 8. So every group of 4 bits that you might have in this long number, it gets a 1, 2, 4, 8 going from right to left. Then you find out, you look at the columns, the places where you have a 1. And because I have a 1 there, I take that 2. And because I have a 1 there, I take that 8. And I just use normal math in my world of decimal, the way my brain likes to think, and I get a 10. Okay, great. So what number do we get here, Ricky, from the one bits in that set of 4? 11. So that we added up an 8 plus a 2 plus a 1. We got 11. Okay, that was all just scratch work there. Now we have an 11 and a 10. Well, what that tells me is my hex final answer here is going to be a 2-digit number, because I had two groups of 4 bits, and this is just the way it works mathematically. For every group of 4 bits, you'll end up with 1 digit in your final hex number. So, oh, but I have 4 digits, 1110. I can't write 4 digits here. Somebody tell me in this period 4, 2014-15, very bright Java class, tell me what my last step is in getting the final answer. Sophie.
You need to take 11 and 10 and change it into valid digits for hexadecimal.
Excellent. The valid digit for the quantity decimal 10 in hex world is A. And Charles, what would I write here for this 11?
B.
Very good. And we always use capital letters. That's just the style. Well done. Hey, what's the biggest number you could have gotten here if all these were ones, Stephen? If all these were ones, what number would I have added up to? 15. Correct, 15. If you had a 1111. Well, guess what? Luckily for us, 15 translates to an F, so we would have been good. If you get 16, there is no G. You did something wrong. You added wrong. 8 plus 4 plus 2 plus 1 is 15. It's not 16. So this just works perfectly. There's the answer to my original red number in binary translated to hex. That saves a lot of time from the otherwise necessary steps of converting this number to some decimal number. I don't know, perhaps 349, and then converting that decimal number to B, A, and 16. That was just more work. This is direct. Now let's apply that system to an octal conversion problem. So let's propose that my goal now is to convert the original number that I had over here, 1011, space 1010 in base 2. Let's see what it works out to be an octal. Well, to do an octal number, you don't group these in groups of 4 bits. It's better to group them in groups of 3 bits. So I'm just rewriting the original problem with that 010 there, and then a little space, and the middle 111, and this 10, it's like a group of 2. But you know what? I'm going to pad it with a 0 just to give it a group of 3. So there is my rewritten binary number. My goal is still to convert it to some octal number. And now let's proceed forward. The next step, because I'm low on time, I'm just going to show you myself without asking a student. But I bet Hannah would have already told me to label these columns 1, 2, 4. There is no 4th bit here, so don't put an 8 above. And Andrew would have then told me to repeat the 1, 2, 4 here, just like I repeated the 1, 2, 4, 8 over each set of 4 bits over here. And of course, we put a 1, 2, 4 here. And now the last step, Brian knows, is to look for the ones and add up those numbers. That was easy. 2 plus itself, 2 plus nothing is 2. Oh, this is hard. 4 plus 2 plus 1, 7. This 2, this 1 turns into a 2. And that is the final answer. There's no A, B, C, D, E, F to worry about in this world of octal. So the final answer is quite simply what you got when you added up all those little 1 bits. This is something you can do in your head on the AP exam. As long as you're decently careful with your math and your adding, you can save time on the AP exam by knowing shortcuts like this and just doing mental math. But trust me, there are problems on the AP exam like triple nested for loops. You guys are former VB students, so imagine this. For J equals 1 to 1,000, for K equals 1 to, I don't know, 50, and for M, the variable M equals 42 to 1 step -3 just to mess with you. And let's make this a step 7, a nice good hearty prime number. And let's make this start at negative 100. Now let's say we have messagebox.show something. The question is, on the AP exam, how many times does this message box pop up? Because of the triple nested for loop. If you had to do this step by step, you would run out of fingers and toes. It would take you all year to figure out accurately how many times that pops up. So you got to find patterns. And that's what we did up here with this slick trick. And these kinds of problems, even when you find patterns, it still takes a long time and consumes a lot of time. So be efficient test takers and use tricks like this to save time. And just in life, anytime somebody asks you to translate a binary number to a hex number, now you know how to do it real quickly.